So welcome everyone. The latest in our series on AI and the humanities. It's a series that's been running all of last semester and will continue through this semester with basically one event a month. Today's talk is going to be on creativity and authorship in the generative age. And I'll introduce our speakers in a moment, but I'll also just look ahead to the subsequent events in this series. So next month, on February 19th, there's going to be a session on responsible AI principles and practice, led by Missy Cummings and Jesse Kirkpatrick. The following month, March 19th, there'll be a session on democracy and civic life in the age of AI, led by Sanchari Das and Sam Levovic. And then finally, we'll have a closing reflection session in April, on April 9th, that Amarda Shehu and I will lead. Today, we're very happy to have with us a couple of professors from the Department of Computer Science. Jana Kosecka is a professor in that department. Her research interests are the acquisition of static, dynamic, and semantic models of environments using visual sensing, object recognition, scene parsing, and human-robot interaction. She's co-author of a monograph titled Invitation to 3D Vision from Images to Geometric Models. And Craig Yu is an associate professor in the Department of Computer Science. He works on computer graphics, vision, human-computer interaction, and virtual reality, particularly on AI and data-driven techniques for computational design. He's the lead inventor of the Make at Home, a pioneering system for automated interior design. We had planned to have a third panelist with us as well, Tema Monroe-White, who's an associate professor both in the Schar School and the Department of Computer Science, but she had a medical emergency and so isn't able to be with us today. But we're very well for this panel up as it is. So I'm going to turn it over to Jana and Craig.
Is this working? Well, thank you very much for inviting us. And so my interest is in images and language. I work both on understanding and generation components. So I'm going to give you a little bit of an overview, hopefully at the right level of technical detail about what these type of techniques and models are about. And I want to really put the emphasis on the data, because as you probably heard, these models are these very large neural networks which are trained using certain data sets. So this is something I would like everybody to keep in mind, because effectively this is where other sources of advances and also the problems come in. All right, so as you probably all played with or experienced, so the language models are very kind of broadly used and disseminated at a lot of different levels. And language models are these very powerful engines for this next word or next token prediction. And token is basically like the unit with which these models operate. And, if these models, they are these large neural networks, which can learn how to predict what's coming next by simply ingesting very large amounts of data. Okay. And, so here is this example. You have Mary had a little, you pass that input to the neural network, and the network predicts some probability of what is the likely next word over a gigantic vocabulary of the words. And the words or subwords, this is just a matter of the efficiency, is kind of the equivalent of this token that these models operate. So it turns out that these models, I mean, especially the early ones, this is some fact from 2023, are trained on about 1 trillion of these units, tokens, which is equivalent about 15 million books or 500 billion words. And the neural networks themselves have billions of parameters. So as you can imagine, with such a huge number of parameters, even though people are advancing the techniques how to kind of understand and introspect what the neural networks are doing, this is an extremely challenging problem. And There is a huge landscape of these models. All the main companies are developing them. There are a lot of proprietary models, open source models. So this is very active research area where lots of developments are being made daily. So let's think a little bit about images, because that's, I don't know what's happening. Now I can't advance. Let's see. Okay. So with language, the elements are words or subwords. So now the question is, what is the equivalent of image generative models? So what is the kind of underlying methodology to generate images? But before we kind of discuss a couple of examples, you can think again that these models are these neural networks, which basically learn how to generate the pixels as opposed to of particular colors. And they learn these kind of regularities of the natural world, which kind of give rise to images which look extremely realistic, right? So they basically pick the correlations and the colors again through some learning methodology and being exposed to large amounts of data. And appeal of this, that then they can create a new realistic images, which are not actually pictures of the real world things, but they also can generate this kind of very creative mystical worlds, which do not exist in reality. So there are two kind of main methodologies how these neural networks are trained, and I don't want to go into technical details, but I'm going to give you a glimpse of one of them. One are so-called generative adversarial networks. So these models are the models where they're exposed to large amounts of data, and they basically have two neural networks pitted against each other, where one is trying to generate the images, and the other is trying to distinguish the real from fake, right? And they are in this game basically playing against each other, and during the process they are improving. So the network which generates the images is getting better and better, making it harder for the network which is trying to distinguish between real and fake process, and they're improving. And then the newer version, which it sort of depends a little bit for the application, are the so-called diffusion models, which basically learn how to generate these images from noise. So let me give you kind of a little glimpse of how that looks like. So imagine that you start with a noisy image. So here is some random image just full of noise pixels, and you want to generate an image of, say, raspberries. So it's very hard to figure out how to swap the individual pixels to the right kind of colors that it's going to give you the raspberries. But it turns out that going backwards is actually easy, right? So if you take an image of a raspberry, you can gradually add more and more noise to it up to the point that it becomes completely noisy. And these steps of adding the noise to image becomes basically a training examples for this large neural network, which will then learn the reverse step of how to remove the noise from images. So that's the essence. It's extremely simple and very effective idea. And the point is that if you have a lot of images of raspberries, then you can basically generate a new random vector, and it will take some path. This iterative process is going to generate a new image of raspberry. So now, initially, this has been developed like for a particular data set or particular class, but you can imagine that this is some visualization how that generation process works, right? So it starts with a noisy vector and it generates an airplane. So this is a little bit lower resolution. Okay, so let me skip that. So now imagine that instead of just generating some images of raspberries, I would like to generate all the fruits, right? So what I can do is I can tell the neural network some condition, which is the word which I'm trying to generate, and that is just another parameter to the neural network, right? So now I have a word, and if the word is mango, it's going to be generating all the mangoes or peaches and so forth. So that's sort of the next step. So if we have this in place, and these are some examples how it can generate different classes, but if this goes a little bit further, instead of just putting in the word, you can put the entire sentence, which the representation of the sentence is basically computed by the large language model, right? So now if you take this generation kind of computational algorithm and hook it together with the language model, that basically gives you a generation which is conditioned on arbitrary text, right? So I can say raspberry beret, and it's going to generate the raspberry beret, but I can say also beret of raspberries, and it's going to generate this. Okay, so this is basically how this diffusion model works. And again, as you can imagine, so this is kind of the mechanism how you can control the generation process. And as you can imagine, these models are again trained on millions and billions of images, image and text pairs, because now the model has to learn how to associate the words with the pixels, okay? And, all the big companies sort of have their versions of it. So DALL-E was the OpenAI model. Midjourney was kind of a standalone. There are a handful of companies which are doing this type of thing. And this enables you then to generate images which have very sophisticated prompts, like, this is the famous Pope in Balenciaga puffer coat walking streets of Rome. And as you can imagine, this could be both used for creative purposes, but it can also generate things which cause a lot of harm. So this is how to kind of condition the generation on text. Then we also have models which just work on particular categories, which cannot be controlled using this textual information. And the most common category are faces, right? Because we have faces everywhere. So we have the so-called unconditional models. And over the years, the fidelity and the realism of faces became extremely sort of high. So these models entered the so-called uncanny valley that is basically impossible to distinguish the computer-generated faces from real. So I challenge you to check how many of these images are the images of real people. What do you think? Which ones are real versus which ones are fake? It's very hard to say.
Yeah.
So this is kind of good to keep in mind, because often you have this news like, oh, we have developed this new technique program which can tell you whether image is real and fake. And one always should sort of note these news with a little bit of the care, because this often doesn't work well enough. So here are some examples. So A, B, G, H, and J are real. And C is generated, B is generated, and so forth. So sometimes you can, for example, spot the differences if you have some deformation, irregularities, or something weird. But again, these new models generate really perfect faces. Sometimes the background can reveal the fact that it's not captured in a natural background. But if you have a real image that is captured on a white background, it could be easily classified if you use the background as a cue, as synthetic. Okay, so this is basically, these techniques I use. I take a random vector, random image, and I generate person doesn't exist. And this can be used in a lot of malicious ways. So for example, LinkedIn, if you need to upload, they can create a lot of fake profiles and you have fake pictures and everything looks like a real people. But it could also cause problem for hiring companies and interviews. And then now imagine that if you extend this to videos, given the fact that a lot of our interactions are actually happening in the virtual world and over Zoom, there are often concerns whether the person you are interacting with is a real person, especially as these techniques are becoming kind of close to real time. So the other type of problems or techniques or methodologies are the techniques where you have an actual real picture, but you do a face swap, right? So imagine that you have a real image or a real video, but you want to swap the face. So here are some examples of face. This is the face which was swapped onto the face of Leonardo DiCaprio with the same lighting and pose. And this is me, what I have tried yesterday. I, took a photo booth picture of myself, and, there is a tool where you can play with these things. And notice that the pose and the lighting and the expression is kind of slightly adjusted, but it looks fairly realistic as kind of me being in person. Now, with this, when these things are, and this is, of course, for often various good reasons, these techniques are also extended to videos. So now, instead of a single images, if you add the lip syncing and audio, then you can generate these very realistic videos. I don't know. We can watch this depending how much time we have. This one is kind of, let's see at the end if we have time to play this video. So you really cannot distinguish it from real. And these videos are getting longer and longer. There are often some artifacts, but one requires really a trained eye to actually spot whether this is a real or synthetic. Sorry. Somehow I jumped.
16,
okay, here. So just a couple thoughts about mitigation strategies. So there is not like one method which would work for all. So there are a lot of attempts. Oh, sorry, I wanted to share that. So there are a lot of approaches that try to detect different visual artifacts, which the models, which are very difficult to learn. So examples are these unnatural facial features, or some lighting artifacts, or blurry parts, or inconsistencies, or say, people not having 5 fingers on their hands, or different background distortions. There's also possible to actually detect some metadata, because when real cameras record things, there's usually information about the camera focal length, and this is encoded in so-called EXIF tags. So for videos, one can also look for some natural patterns. Everybody has their own gesturing and blinking patterns, which in some sense correspond to some video biometrics of the person. So these are techniques which have been used, for example, to detect some face swaps for videos of politicians who were saying different things than they were actually intending to say. And there are also different audio and voice synthesis techniques. So again, this is a very active research community, but this is extremely multifaceted problems, and people are continuously trying to expand the set of tools to automate the detection, but effectively, there's always kind of human in the loop, which is checking for some of these inconsistencies. Another strategy is some kind of media provenance, right? So you try to actually mark the generated content. And so there's a lot of discussions between the companies to provide watermarks or tags to actually say up front this was generated. But as you can imagine, with such a large landscape of these models, this is very hard to enforce across the board. But the big companies are kind of trying to do this. Now, mind that this is also possible to remove. So if you are an expert, again, this is something that can be beaten. So this is the labels or digital watermarking or this blockchain-based verification. So this is basically happening at the creation side. So here is kind of some simple example of the complexity of the fact-checking workflow. These are, often these experts which work in these fields are often being approached by journalists or different agencies to verify something. And again, it typically uses some combination of automated techniques, which sort of flag, depending on the amount of data, which flag some suspicious images. But effectively, it is the human who goes and verifies, because some of these artifacts are very specific for each image. So this was an image which was disseminated on Twitter when there was the helicopter crash in Potomac. And then at the end, they basically determined that it is AI-generated images because there were some kind of weird blue flares in the water. Here, the cars usually have 2 sets of lights as opposed to 1. There were some humans which the sizes of the humans were disproportional depending on the distance. So it's really like very subtle cues which we as humans can more naturally recognize, but it's very hard to build automated techniques to do so. And so, there are also positive use of these AI techniques. So as you can imagine, this is really kind of democratizing the content creation, and it's very broadly used or in advertising, personalized marketing, virtual fashion, try-ons. These very similar techniques could also be used to enhancing videos. And recently, what we are seeing that these methods are actually used to generate training data for the models which are trying to understand the videos, right? Because this is kind of an automated way how to generate training data. So a lot of positive applications as well. And that's all I have. I'll open it for discussion. I mean, I'll be happy to elaborate on any of the topics. Or I don't know, maybe Craig, if you want to go next. What do you
We'll have Craig do his
Okay,
presentation,
sure.
then we'll do an
Okay,
audience.
so
one.
let me. You wanna?
And you're sharing from the same computer?
This is the. Let's do it. Okay. You share. Hold on, I'm gonna change the. Share. This.
Can you share the slide?
Yes.
Yeah. Yes.
I have to put my notes.
Sharing sound from that computer.
It's
We
asking
can
me
see
to add the.
how it goes.
Sure.
Asking me to, I'm putting, asking me to share the password to do that, but it's not taking my password. Oh, I think. Okay.
Okay.
Did you wanna?
You might hear it in the room better than they will on Zoom, just to let you know.
Random image into a Raspberry image. But it's relatively easy to go the other way.
Is it meant to be?
You just need to add more and more noise until the pixels become
Where is
totally
that from?
random. You can think of the animation I just showed as a path through the space of images, where each frame is a single step towards more
Is it part of your-
randomness.
No,
Or is it not?
no.
Now, what if we
Mine
played
is
this
just
animation in reverse?
Is the ghost in the machine?
I think so. I think it is on this computer in the background.
But I
Just
have,
the videos.
but I have no.
Yeah, that needs to be. You have other windows open.
Oh my goodness, I have a lot of windows.
I can also try.
Yeah,
Sharing
you,
here.
yeah,
You wanna
and also
go
use
to-
your computer.
It'd be better if we use this, but
Sure.
he doesn't have access to the.
Do you wanna? do
I'm gonna go
that?
ahead and try. Yeah.
Okay,
And you have
Let's
the-
just mute you again. Yeah, I have yours
but
open.
now it's, okay, well, why don't you try that?
Yeah.
You have the link to my
I
slide.
don't know.
I have it
Okay.
open here. You should be able to.
Yeah, and then share sign. Yeah.
Thank you.
Okay.
And again, we'll probably hear this better in the room.
Okay.
I'm going to mute us.
Yes.
Is this gonna work? Yes, okay, I'm gonna mute us until the sound comes, so you just gesture when it's. Is it just in one slide, your sound?
I think in a few slides, I have, yeah, in 2 slides, I have some sound.
I'll
Thank
unmute. They can still hear you up here, but I'll unmute my computer for the noise, for the sound.
Sure.
When we get there. Okay, sorry.
Alright.
We're working through it.
Okay,
Okay, and we'll just want to stand a little bit more. Now you're on screen. Thank you.
okay. So should we play the slide?
Okay, I'm gonna
All
do
right.
this.
Yeah, all right.
How does that work? Do you want to sit or stand?
Okay, so just do this. Yeah, we're good. And
I might have to do the same thing, request access.
to peer permissions. Not sure if I need to give the permission, but I think it's okay.
Okay.
Yeah. Yes. Okay. So first of all, yeah, thank you for coming, and Jana gave us a very good introduction to the topic and also talk about the major concepts behind the generative AI models that are very commonly used these days. So I come from the content creation, computer graphics background, so I'm going to give you some examples of how generative AI is being integrated into the content creation pipeline these days, and also what kind of applications, new applications, that may lead to. So first of all, about the sound, about the music side. So generative AI has been applied, right, for creating music, for creating sounds, which is very important for, like, imagine like you have projects like creating games, creating animation, creating some kind of content for the YouTube. You need background music, right? You need the sound effects for different things. So there are companies that already incorporate like generative AI for doing so. Well, I just search around, see what kind of tools are available out there. The company that allows you to, you can kind of reverse engineer a piece of music, right? So you can upload a piece of music, and then you can get back the sheet music, right, with all the notes and all the music notations, right, so that you can use that as a basis for playing, right? So with your instruments or with some computer generated sounds following the music sheet to play the music. So another example, so for AI generated background music, so this is a website that allows you to specify the type of music you want to have. Like, for example, if you have a game project and you want some kind of music, background music that will fit with the mood of the game, then you just type in the text describing the vibe you want to generate, and then it can generate the music for you behind the scene. For example, I tried it last night, trying to generate something about a relaxing desert, and this is what I get. After a few minutes of generation, oops, okay, now.
On my computer right here. Gonna start it over.
Okay, yeah, sure.
And then we'll try to be quiet while it's playing, otherwise we'll
Okay,
echo.
yeah, just a few seconds. Yeah. So this is something. So this is something generated after I type in the keyword, the relaxing desert. Well, of course, I'm not the developer behind this. I don't know how exactly they model this generation process, but you can imagine you can easily apply some existing model like LLM for doing such synthesis, right? So if you imagine, if you regard the music as a sequence of notes, right? And you can have lots of samples like this, right? From the internet, you can train an LLM to be able to relate the textual description of the piece of music with the notes sequence, right? From lots of examples, then LLM can pick up this and regard this as a sequential synthesis problem for generating, music notes according to the designer's input, right? So you can apply a similar model for such synthesis. Although by profession, I'm not working on the computer music synthesis side, but I can imagine like such approach should be possible. And so let me see. And this is something my students and I worked on a few years back. Actually, it was done already 6 years ago, so there should be some progress along this direction. But basically, the idea is that we want to link the visuals with the sound synthesis side, right? So imagine, so this is like a comic book, right? So of course, the comic book only has a dialogue. Usually, it doesn't come with any voiceover, nothing you can hear about. So but you as a human, right? Like reading the comic book, I think not many people when they read, they try to narrate by themselves, right, in the brain, right? So you kind of have a estimation of the voice of the characters, right? So a few years back, we worked on this project trying to create a AI engine that will be able to analyze the characters on the page of comic and then generate the voiceovers automatically for all the characters, right, on the page. So I can show you an example page with some of the results. So for example, this one. So all of this is automatically generated. So given a page like this from Marvel, so we can generate the voiceover. I need to turn on the sound.
Perfect.
Okay, so let's try again.
I remember. I was trying to save his life.
Hello, gorgeous. Brought a friend.
I do hope you're up for visitors.
Marvel. What happened here?
You saved me.
So all of these voices are generated, automatically generated. Okay. So what's behind the scene is that given a page like this, so our engine analyze all the available characters in the scene. Of course, the engine doesn't know who are the Marvel characters and who are who. It doesn't have any idea of that. We don't assume that, right? But what it can recognize is the number of characters existing on this page, right? And also the kind of estimate the age of the characters, the gender of the characters, which may affect the voice, right? And also it can recognize, it can apply the emotion recognition to estimate the emotion of the person while speaking something, right? So all of this can be estimated by computer vision techniques. And then based on that information, we generate the voiceover accordingly, right? So of course, first we generate kind of like a base voice for each person, but then according to the emotion of the person while speaking something, and also from the sentiment of the text that we can extract from the comic book, then we adjust the tone of the person speaking, that speech bubble. Then combining all those, then we can automatically narrate the whole page, right? So this one example, I can show you another one. I don't know which one. So we have a bunch. This is from Magic School Buds that my daughter liked to read when she was a little kid. I can show you this. Okay.
Oh, the forest. Where since the beginning of time people have come for peace and tranquility.
So from here, and
Shh. I'm trying to hear the trees, you guys. Please, please, say something.
I knew it. Nothing to hear here.
And true, I hear animal noises.
okay. And then,
But is that noise, or is it communication between animals?
Noise is sound without meaning.
And communication is about sending a message.
so this is all automatically generated as well. You can look at it as an example of how we can apply generative AI to enrich our experience, right, with the traditional media, right? So if not using the AI, well, of course you can hire someone to do the voiceover, but that would be a huge amount of work, right? And it's not as scalable as before. So just one example, and now go back to this. Okay. Okay. So I talked about some sound or music related example. So there are other examples that we worked on. For example, one direction of my group is to generate computer animation, right? Character animation, right? So for example, we may have a restaurant scene in a movie, right? Or in a game environment, right? So if you want to create animation like this, so the traditional way to do it is you hire an animator, right? And the animator needs to think about the script for all the characters for doing the motion, right? And then the animator is to create the frame, one by one, right, to generate this. So even like a short snippet like this will take quite a long time to design and to animate, right? So basically, the idea we have is we create a generative AI behind the scene so that just given some very high level description of, what should happen in the restaurant, right? And then the engine should be able to take care of the whole synthesis. So here, what you see here, like the characters here, the object here, and also all the actions here, they are all generated automatically, okay? So we just tell the engine that, hey, this is a restaurant environment, so please just put something that makes sense here, right, in this environment, which is something like this. Well, so behind the scene, so we formulate it as a graph neural network problem. So I don't want to touch into the low level details, but basically what the computer understands is that, each moment like this can be encoded as a graph, right? So a graph with the nodes denoting, who are the people in the scene, right? And what are the objects in the scene, and what's the interaction between the objects and the people in the scene. So all of these can be captured in kind of like a graph structure. And we train a graph neural network to learn about the progression of this kind of graphs. Okay, so that we can even ask the graph neural network to generate some new sequences, right? That would correspond to some realistic actions. So by doing that, so we can have the generative engine to generate like animation snippets like this. So this is another example. So this one actually was captured in my lab at the Fairfax. So similarly, so these days, I don't know how many of you have tried like virtual reality or augmented reality. You do put on a headset and you can see like virtual characters around. But this is something probably up and coming and will become very popular in the future. Like glasses may have augmented reality capabilities. So this is something my student captured. So what you see here basically is a augmented reality story automatically generated for the environment like this, right? So if I put on a glass here, probably the characters will sit here. I will see some virtual characters coming and they sit here. So again, this there's a AI-driven approach running behind the scene, trying to understand what are the available objects in the environment and the spatial arrangement of the objects. Like, there are some chairs here and some chairs are vacant, right? And then based on that, what would be a possible story to happen here? So for example, maybe there are two other audience coming and sitting taking the vacant chair, right? And sit down there. So this is something like we can envision. And of course, we are not limited to indoor experience. So this is outdoor. Probably you recognize where this was taken, right? This was taken outside the Horizon Hall, So basically, same, you wear the AR headset and you can say you want to see some kind of, creatures flying around the campus, right? So the approach behind can analyze the environment, right, based on the digital twin of the environment, and then generate the dynamic behavior of a creature like a dragon, right, flying around and doing things, compatible to the environment, right? So like, flying from the sky down to the ground, and it is to take a rest, and then it goes towards the user and so on. Okay, so yeah, so I've already talked about some examples, right, from the music side and to the research side. So I'm just trying to think about the future, right? So, I used to play this kind of game on a TV screen, well, but who knows, in the future, maybe the world is a playground, right? So you can have the AI being able to understand the scene, analyze the scene in real time, and then generate some kind of interactive experience, right, on the fly, right, or gaming experience on the fly, so that you can watch the characters, right, playing in the environment in front of you, or you may even engage in the gameplay, right, in the real world. So this is something I found on the internet, right? Someone created a augmented reality Mario game experience to experience on the park, right? In the park, right? So basically, you wear the headset, you walk around the park, and the program behind transform this into a Mario level that you can play with your body physically. So this is something, I don't know, maybe my grandson or like, I don't know, will play every day. But this is not a dream. This is not a dream. So this has already turned into some commercial product. So I check. I like this game, Mario Kart. It was one of my favorite when I was a kid. And actually, in Taiwan, so they released a version of the Mario Kart that you can play in augmented reality. So this is a real product, right? So basically, this is at your home, and you can put on tracks. Take it home as a virtual track, and have the Mario Kart car going along, right? And this is what you see. So basically, you control the car, and there are like virtual objects that are generated by fitting with your home layout, so that you can do like racing game in like an augmented reality manner. So this has already become a product, and I expect more to come in the future as the AI and the different schools of techniques continue to progress. So yeah, so this is basically what I would like to share. But we'll have discussion and Q&As. So look forward to that. Thank you. Done?
Thank you both. I think we'll invite you to come back up and sit. We can launch into the audience discussion now. I invite anybody on Zoom to submit. I saw we had one in the chat, but you can also, oops, sorry about that. You can also come on screen, come off mute, and engage with us that way. So I don't know, Luke, sometimes you like to launch us off. Would you like to today, or should we?
What would it be if there was already a question? Do we want to maybe just start there? And
yeah, and Vivek, would you rather we read this out, or would you like to come on camera? Well, I will start reading it out, and then feel free to interrupt me if you'd like. All right, so this is for Jana. So thank you for all the informative and candid presentations. You mentioned that there's a set of problems for you. I'll put this up so you guys can read it. Sorry. Here we go. The biggest set of problems for you comes from the nature of the training data set. I don't believe you elaborated on this. I can understand what these kinds of problems would be for a text data set, but I'm not sure what they would be with images. Thank you.
So there are these kind of traditional biases you can imagine. So for example, if you ask the system to generate an image of a CEO, it may be a man, or an image of a nurse, it may be a female. But again, when you have this text conditioned prompting, now you can be more and more specific, right? So there is a way how to control this. I apologize. Yeah. So this is one thing which comes to my mind. Yeah.
Should I find you some?
Yeah. Yeah.
Okay. Yes. It was already here. Is it yours?
Oh no, it's not mine. It's okay. So don't worry. I mean, I'm a little bit of a cold, so I think it's just getting irritated. But I'm good. Sorry for coughing.
I'll go get you.
No, don't worry about it. It's fine. I think I'm okay. It just sort of comes and goes. Right. So I think these are, or for example, you can imagine like the variety of things. So if you have a certain object you would like to generate, in the real world, this object comes in a variety of poses and viewpoints and sizes, and this is very hard to control using the natural language. So for techniques that actually analyze some of these created or generated images, you can actually go to the training set and exactly understand why the object was generated in such a way, because the only training data which, I don't know, relate to, I don't know, Hulk in some victorious pose are exactly handful of images which are in that pose. But if you would like to do something different, sometimes it's hard to extrapolate. So, right, so it comes in kind of these obvious ways as this CEO and nurse, but also in these very subtle ways, which are kind of the poses, the viewpoints, the appearances, which are very closely related to what was seen in the training set.
Ask the question if I can. For both of you, I'm just curious about how you think about the difference between developments that are tending towards sort of replacing human creators with AI generators of some kind or another, and other kinds of developments that are enabling rich collaborations between human creators and AI tools, I guess. And if you could just say, your sense of what's going on in the field in relation to those two different kinds of paths, whether one path is really where everything is going, or whether there's developments that are pushing in both of these directions, whether it's up to users depends on how they use the stuff, whether it's collaboratively or this more taking the place of human creators, just your sense of that kind of issue.
Something along these lines which comes to my mind is that, so different people have, I guess, different level of creative ability or style, right? And if you have, it's very hard to actually impose this onto the models. So one big issue is allowing the users the more control of the models so they can sort of take advantage of the efficiency, but at the same time express their own vision and style. And this, I think, can go in lots of different directions, right? So this is why I think it is very effective for people who are actually not very good at these things, right? That's where the idea of democratizing comes, right? Because you do not need kind of a designer in order to generate some infographics for your product. But if you're a true artist, then you want to kind of create some vision. This is where these kind of technologies are in some sense against each other, right? Against maybe your vision, because it's very hard to control it. Because right now the interface is only, the basic interfaces are only the language and the generation process, but people are working on techniques, how you can say, add a sketch because you want to have the character in a certain pose, right? Because you have some idea how this should look. So this is, I think, at least a couple thoughts at the level of working with these tools and how they kind of both support and hamper creativity in some sense. And for the collaboration, I don't know, do you mean between people or what kind of collaboration?
Well, I was thinking between a person and an AI tool.
Yeah, so I guess this probably is also along these lines, this answer.
Yeah. So if I were a content creator or digital artist, well, at the first glance, I may see it as a threat, right? Because usually, people pay me to do the content creation now. At a single click, people can get what they want, quote unquote what they want.
Mm-hmm.
Well, so that could be a threat, right, to my job. But if you think more deeply, that may not necessarily be true because, yes, the AI is able to automate the creation process, and it can automate a lot of tasks that used to be done routinely, right, in a very laborious manner. However, it doesn't really replace the truly creative part, right? So what I mean by truly creative part is the idea itself, right? So the creator, instead of spending a lot of time doing all the manual adjustments to create a product, now the creator needs to focus more. So the creator doesn't need to do that anymore, right? Because AI is automating that part. So then actually it frees the creator's time up for thinking about the idea itself, right? Making sure the idea itself is creative enough, and also, the person may need to spend some time to also curate the process, right? So talk to AI from time to time, try to communicate what's the idea behind, and then trying to work hand in hand with the AI to converge the design to that vision. So I just think if you think more deeply, then it would just be like a different allocation of time rather than like totally replacing the designer's work. So that's how I look at it. Well, as an example, so you can think about other pieces of software like Photoshop, right? Before Photoshop, before like photo editing software, it's very hard for people to retouch a photo taken, right? You may need to go to a photography shop for doing all those editing. But now with the Photoshop, with a photo editing software, lots of people can do the retouching, right? So basically, it makes the content creation easier and more accessible to lots of people. And I think that it's just that the mode of creation, the mode of working is shifting, and people need to get used to the new style. Yeah.
I think your hand is up first. Go for it.
Me?
Yeah.
Okay, thank you. My name is Liang Luo. I'm the chair of Modern and Classical Languages. I'm here with our dean from CHES, College of Humanities and Social Sciences. And we teach like 15 languages and its related literature, culture, including music and art. So I'm really interested in possibilities for collaboration at multiple levels. So I can give two examples. One is micro. For example, I'm teaching science fiction this semester. And one of the creative projects I want to assign is having them to write science fiction or creating science fiction ACG works, animation, comics, and video games. So I'm wondering what kind of collaboration I can have with you, maybe send my students to some sort of interning experience in your lab. I'm just making it up. So I'm very interested in that at micro level. But at the macro level, for example, I'm creating this global art initiative, which is spelled out as Global Asia's Research and Creativity Hub. So I'm interested in like larger reach across campus to get collaborators in terms of creative work. One example, for example, if we want to create an interview oral history-based AAPI graphic novel or audio comics, as you suggested, or some sort of video game and animation, can we, collaborate on such a project, maybe get funding together and really create synergy and have sort of a community impact, right, for such a project? It's just one example. So I'm very interested in collaboration at multiple levels. Thank you.
So I think, one immediate thing which comes to my mind is that we are kind of familiar with all the tools, right? And so even kind of communicating that, or maybe doing some demonstration or pointing to some tutorials how to use these tools, because when you do a Google search, it's very hard to kind of orient yourself in what to try. So I think this is definitely one thing which maybe could give you some ideas what kind of exercises and things student can do, on what they can try, how they can do a little short stories, and then also how to kind of evaluate it from your perspective, right? So, and I think this is probably more relevant for like the video creation part, which is really kind of ramping up right now. So, what I have demonstrated is mostly the static case because it's easier to kind of explain the technical component, but the extensions to video are really sort of main focus. And this goes both for like a creative component. You can have like a little short movies and films in mystical worlds, but you can also generate fake news where you have the actual videos of anchors interacting with the subjects and so forth. Yeah.
Reach out for tutorial.
Yeah, I'll be happy to send you some pointers.
So
content creation, yeah.
Yeah. So what you mentioned actually reminds me of some fantasy I always have, right? Like, I like to read novels. I read a lot of novels when I was a teenager. So, well, all the novels are, of course, they're text, right? So, but something I always think about as a fantasy is like, can we really experience the world described by those novels, right? So, well, movies, games, they're trying to do that, right? So there are games and movies that are based on the stories of the novels. But now that we have a like very powerful AI generative model that can turn text into images or videos or music or games, sounds in no time. So I think that could probably make this game dream come true, right? Because you have the text and you can have the AI to generate all that content to you, right, instantly. I think that would really unlock the like a new era of how we can experience fantasy worlds and imaginative worlds. Well, and that has practical applications. It's not just a fantasy, right? So think about museums, right? Think about tours, right? In the real world, right? So like for example, so I remember I brought my kid to Williamsburg, and Williamsburg used to be a colonial town, right? I remember there was a street that decorated like in the colonial time, right? Well, if we have AI, right, for generating the automatic content and given the text description of what the past was like in that area, well, we can generate that visualization in no time, right? So that can help people really understand, like, what that world described in the book, in the text is like, right? So it's very helpful for like history education, also for natural science education too, right? So you can generate like dinosaurs world, so you can get in the place and understand like what exactly like in that age, right? What are the creatures like and what are they doing, right? So I think it's a very powerful tool as for education and science education, history education, and so on.
We've got a question. I know Todd had his hand up, but I wondered if I could just jump in on the note of collaboration, because that is, after all, one of the major goals of the series is to get people exactly like you three to speak. And I hope you can find a time to chat outside. But Craig, I wondered if you could tell us about the collaboration you have with the School of Art. So you're working with John von Bergen, aren't you, with his virtual reality?
It's the School of Art. Yes, John, right?
Yeah.
So
exactly.
he works on
Just
sculpting.
to say, like, this sort of stuff is actually already happening, and it's really exciting for
Right,
campus.
right. So he works on sculpting,
Yeah.
right? I mean, the traditional type of sculpting. We are thinking to collaborate because I work on virtual reality. So we can use virtual reality as a tool for people to experience sculpting, right? Not everyone can afford it, like an art studio with materials and stuff, right? But it's very easy for people to put on a headset and then just immerse into the like a studio-like environment, right? And try sculpting digitally. So actually, we are thinking of actually organizing a contest of creating virtual reality content, right, based on like sculpting techniques for purposes like STEM education or STEAM education. So we are organizing something along that line, and we'll have that soon, actually in spring and in summer.
We're also collaborating with them on an
Sure.
event, so
Definitely.
we'll chat about that later.
Yeah, sure.
But sorry about that. Todd, please.
No, wonderful. Thank you both. I wanted to invite you all to speak for yourselves, but if you're willing to sort of hazard like a more broader generalization about your sort of scholarly research communities and how they think about the question I'm going to ask, which kind of pertains to the data sets and the inputs for your tools and how your community or how you individually as researchers think about those in relation to what we might describe as, on one hand, the sort of moral rights of creators, and on the other hand, something that's a little more like copyright or licensing. So to elaborate on those two bits of the question, in the moral rights in your presentation in the sort of category of positive applications, you had the Ghibli the Ghibli generation, famously, Miyazaki described AI generated images as an affront to humanity in 2016. And then when Altman's company decided to, release the Ghibli machine, he commented pretty directly, yeah, we chose that on purpose and for that reason, basically. So there's this sort of like moral question around the input data. Obviously, that couldn't have been outputted without the tool having taken in the Studio Ghibli inputs. And then on the copyright side, or licensing side, there's this sort of big division between, for instance, Midjourney on one side, like a real sort of open source, information ought to be free philosophy. And then something more like Shutterstock, where it's like all this licensed content that's been taken into their AI tool. And for creatives, there's a huge price difference between using those tools. Shutterstock price to license an image for commercial use from their AI tool is starting to approach the price of hiring a photographer. And so I'm just curious, like, how in your community do these two issues come up, or how do people think about, do the creators of this content have some kind of moral rights to the content? And what about this licensing legal side and what it means for the economic viability of the tools?
So I think as these tools are getting better and more usable, I think these issues of authorship licensing are kind of being worked out. They're often actually being worked out in courtrooms, right? So there are a lot of lawsuits going on where people are trying to kind of figure out, what are the kind of consequences and possible penalties of doing these type of things. I'm not familiar in some of the details, but I imagine that throughout that, all of this is extremely new, right? So it takes a really long time to kind of get familiar, to kind of understand the landscape. There's really only kind of handful of experts which kind of span both sides, because often, when you have engineers, they're not so educated and well-versed in some of these legal and moral aspects, and often don't even think about these things. So they are more like driven by the technical components. And I think it's very important to educate people in these areas. But I don't have kind of a good concrete answer, at least on my side. I don't have enough kind of personal interactions with some of these users and owners.
Thank you.
Yes, so I I know where you come from. I
don't come from a particular experience.
the problem that you found out. Well, I like drawing. I like create art as a hobby, right? And I would feel really bad if an AI just copy my style and generate lots of replicates of that, right, without paying any credits or royalty to my work. So I would say ultimately, I don't know how that could work, but ultimately, if we have the technology being able to trace the source of the data where the AI learn all those machine learning models from, so that we can pay the original creators back some form of royalty, I think that would create a very powerful system for motivating content creation, actually. But if we can have like some kind of watermark or like some kind of, like watermark or digital, footprint to trace back like the source of the learning, that would be very powerful. But so that would ultimately motivate people to create more, right? Because they are going to be credited and also get royalty, right? Even like AI, like copy style and generate stuff based on what they created originally. So yeah, that's my take.
Yeah, so like I'm aware, for example, of big lawsuit of Getty, which is suing OpenAI. Okay, so I don't know what's the outcome of it, but there is definitely a lot of pushback from the content owners, right? Now, there is, in the research community, there is a big push for open sourcing. Now, and the open sourcing also then goes for the data sets, because there are techniques that if the data set is open, that you can actually go and attribute the sources which contributed to generating of the new content. And this would be a mechanism, say, maybe for distributing these royalties. But the big companies don't want to open the data sets. So.
There's sometimes this kind of question in the LLM kind of context of what the future development of that technology looks like, whether it's approaching a kind of limit for the kinds of capacities that it's able to develop, or whether it's a trend that will continue expanding capacities as the scale in different senses is enhanced. I guess I'm wondering in relation to the different kinds of domains that you've spoken about, the visual, the auditory, like there was another dimension, but I cannot remember it right now. Whether there's similar kinds of issues of what the path forward, what further enhancements are possible and what those paths forward would look like, or whether it's a kind of sense that is it a sense that one's at an incipient phase and one doesn't really know what's possible, what might be possible, or is it a sense that you're at a relatively mature phase in relation to the technologies and the sort of capacities are well evidenced and it's a matter of improving them, but not necessarily significantly new things beyond that?
So I feel that, the techniques and technologies are kind of quite mature, and there were huge advancements in the past decade, right? So in the sense that the things we didn't know how to do, now we know how to do, and they work reasonably well. So now, in the majority of the cases, they can be improved by having more data, right? And then, adding more constraints and so forth. So this is at least at the generation side. But the rest kind of very much depends on the use cases, right? You want to use the language model for coding, works for something, doesn't work for, you want to use it for reasoning? Well, let's talk about what kind of reasoning are we talking about? Do you want to use it for synthesis? I can easily kind of come up with the prompts where things just simply do not work, right? So every domain has this long tail, right? And right now the action is in the long tail, right? Because the long tail, it's where the application domains sit. And if you take some niche application domain, the kind of the general things usually do not work well. So I think that's kind of one direction I think a lot of the research is heading to. And the other is this kind of continual learning and update and trying to kind of has these interactive systems which you improve with over time while you are interacting with them. Because right now, train the model, the parameters are frozen, and then that's it. So you don't have that ability for the model to improve as you are interacting with the model in your particular domain. So these are kind of interesting technical I think questions and issues people are thinking about.
Yeah. I think from my personal experience using the AI, where I also looked at lots of issues from the user experience that needs to be improved, right? Like hallucination, right, is a big thing. Sometimes you ask AI, right, to give you some explanation of something. It may lie in a very convincing way, right? But if you ask further about the sources and the references, well, at some point they may admit that they actually don't have that, right? So that's an issue, right? So another thing is if you use it for image synthesis, video synthesis type of thing, well, you can generate something that looks very fancy, but that may not be exactly what you want, right? It actually takes quite a lot of time for you to communicate with the AI to get it to generate something that exactly serves your purpose, right? So like, I have a slide, I need an image to show a certain idea, usually it takes you, I don't know, like 50 minutes, 30 minutes to talk to the AI and iterate multiple rounds in order to get something that is usable, right? So I think all of these are like practical issues that really need to be solved in order to incorporate AI as a standard content creation component. Yeah, that's how I look at it.
I had one more kind of comment to the earlier question when we talked about the virtual world. So one part that I didn't talk about is that the models I mentioned, they're all just image generation models. But you also have developments in generating the 3D models, right? And those are the kind of models you can do a walkthrough in the type of virtual games what Craig was talking about. So this is, of course, of big interest to Hollywood because that could basically remove the costly burden of production of a lot of these sci-fi movies. And it's sort of very appealing that you can generate now not only the visual images, but the actual 3D models that you can walk around and things look geometrically consistent and realistic of these non-existent worlds. So
actually, I want to add to my answer to your question. So I think because I also work a lot on using virtual reality plus AI for training and education type of applications, which I think is a very important domain of application. I actually feel that one big problem is the reliability of AI for such applications, right? Think about you use AI plus virtual reality to train people to do surgery, right? And you rely on the LLM to give you feedback on whether this is the right step, what should I do next? Well, if it hallucinates, that will be a huge problem, right? Like, okay, I do this cutting and that's done, right? And AI said, oh yeah, that's good news. And actually it's hallucinating, right? It's trying to flatter you with some fake information, and that would be a huge problem, right? So for like lots of mission critical applications, can we really rely on the AI or the LLM answers, right? As a basis for a decision? I think that part is really huge, right? If we want to use it in a serious manner, right? Like, surgery is one example, but there are many other examples like that, right? Like for military, for healthcare, for like education, we can rely on like wrong information, right? Yeah.
I have a question. I can. I didn't see a hand up, so I'll jump in. So I'm an art historian, so I think a lot about art, obviously. And one of the funny things about that field, or I think art in general, is like no one has one definition of what that is, right? And I think like for me, one of the important parts of art is that it's filtered through like a subjective human experience. But you could take the example of like a dog holding like a paintbrush and like making a painting. Like, is that art? We can, maybe it's still subjective kind of, but it's not, it's not embodied in human experience. I swear this is going somewhere. So my broad question for both of you is, does AI really produce art? Like, do you consider either the audio or the video or the visual output, is that art? Like, don't we have to be there to appreciate it? Like, how can isn't it like, you don't go outside and say, oh, well, this leaf has fallen off the tree in such a way, this is art. Like, it's happened without human intervention or human appreciation. So like, would you say that AI creates art, or does it create art at the moment we encounter it? Like, where do you kind of situate the definition of art with your technical expertise?
So I think there are a lot of interesting discussions about this in our community. And one, I don't know whether popular or not popular opinion is that, that in some sense, the art is kind of for consumption and interaction. And, as long as whatever gets generated serves that purpose, could be considered that way.
So if there's a human who is
Who is
consuming it?
consuming it?
Okay.
Yeah. But this is just, like a tiny sliver of opinion that I encountered and in, this discussion tend to be sort of quite philosophical as you can.
Yes, I know.
But I have,
Yeah, I think, it's a difficult question to answer.
It's a good question, I admit.
Yeah,
but-
it's always been lots of debate.
But we're
Um,
talking about the concept of creativity, but like, is it? I mean, I guess I'm just like trying to figure out like the biggest questions here. Like, is this creative action or is it just computers making things or hallucinating, as you say, or like?
that is a creative.
I think my answer is going to be subjective, but I think that true art should have a humanity component behind. So it's not just like generate something beautiful. It
Right.
is to help the artist express his feeling or perception of the time and the environment. So for AI generated art, if it doesn't have that component, I think there's something missing here. If we consider it as a piece of artwork. It is
like-
subjective, right? Different people
like
may have different
output-
definitions of art. but-
Output versus art or something like.
Right.
Anyway, I won't bother you too much longer with that.
Another sort of appealing analogy was, I guess, when photography was introduced.
Yeah.
There was like a lot of discussion that, like the painting is gonna go away, right? So this is, if you kind of consider that type of analogy, you can argue that this is just another medium. We are kind of expanding in our ways how we can express ourselves and tell our stories. So that's, I think, more of a comforting, like painting didn't go away, it just became a different form. And again, depends on the qualities. Yeah, it's quite subjective.
Yeah, I think like, I'm pretty sure you have seen lots of artworks are generated by AI. Well, my personal feeling is that like when I see those artworks like on social media, like generated by AI, one thing different compared to when I see a true piece of artwork created by someone is that I won't try to think like, how do I say? Well, when I see a true piece of art, right, in the museums, I will try to feel what the artist tried to express and what the artist feel at that moment when he or she created art. But when I see an AI generated piece, I won't think about that part because I know this is generated, right? There's no point thinking about that side. And I think that is the critical thing missing behind the AI generated art.
It might be like the speed and ease of generating as opposed to, that like thoughtfulness process.
Right,
which,
exactly.
Because, if you embark on making a painting,
Right.
usually it's much longer process.
Right.
To kind of think about it,
Yeah, exactly.
Yeah.
Yeah, so that's the humanity. That's the thing about the missing humanity component I mentioned. Yeah, I would say. Yeah.
Out again?
Yeah, but if there's anyone else, they should go.
No.
So I was talking about this theme with someone else after one of the previous CHR events. And, we kind of observed that in a lot of humanities fields before the advent of these AI tools, there was at least a sort of huge group of folks that were basically like all of this emphasis on creativity and originality, it's really historically and culturally specific, right? Like that, like this idea of the expressive human that's, passing their true insight to us. That's actually something that happens at a particular time in human history. And actually most human expression and creativity isn't really imbued with that special, like the artist quality. And so we got to talking about the places where that sort of still exists. And, one of them to some extent is in like folk dances or something like that, where there is some creativity in the instantiation, but actually you're within a tradition, your moves are sort of scripted and ritualized. And that led us, there's a specific do you know about question in this. And that is, we wondered whether there might be any initiatives to take video of dance and translate it into the recognizable notation that dancers and choreographers use, and vice versa using AI. Neither of us had heard of it, but it seems like one of those things that the tools might be powerful enough to be able to do now. And a big problem for people that do, do sort of anthropology of dance and related disciplines is really getting these videos, these sort of field recordings into a form that dancers can see. And then also there's a bunch of old forms of notation that people can't really read very well anymore, that scholars have sort of lost the ability to engage with. And so is anyone working on that? That's sort of like dance to notation translation using AI that you're aware of?
I actually had a meeting earlier in the morning on this topic. So, couple thoughts, there are a lot of advancements in modeling motion of human bodies. Right? You have sports and this is both the generation but understanding, right? So there are the kind of two ends of the so the understanding, you can think you have a video now, describe the motion at a certain level of granularity. Now, if you think about it as a training neural network problem, you need to have kind of examples and language for describing that in order to be able to, show the model a few examples and then be able to extrapolate to all archival videos of dances of particular style from particular region. So yes, there are advances, but the details matter, right? I maybe just wanted to say that there's specific models which are devoted to understanding humans, which is not something I talked about. And the reason for it that we are humans, we have a lot of data about humans, we take pictures of humans, we take videos of humans, the humans are everywhere, and there's a huge amount of applications which could benefit from kind of having human-specific understanding, body structures, weight, the way how we execute things. So this is completely separate effort with lots of activity. And so I don't have from the top of my head some pointers for the dance-specific things, but I suspect they can be found, yeah.
Cool.
Or looked at. So in our group, we work on sign language, right? So the problem is the one where you say something in a natural language and you want to have an avatar signing. And sign language is extremely complicated, right? The gestures are elaborate. You have lots of different stuff. It's very fine-grained, so some slight variations completely alter the meaning. So some of these models, we are exploring how to use some of these models for that.
What about the other direction? Like, can an AI model recognize sign language video pretty well and translate it?
So it works very well for simple isolated signs. The direct translation, it's not quite there. It works much better for, say, British Sign Language, partly because people took a lot of effort to collect the data. So it's all kind of the efforts in creating data, training the models, and so forth. And the more effort it takes to collect the data, often the less reluctant people are to take on some of these projects. So there is this continuum of what is the effort to get the data and train the models, right? And so it depends where you sit on that continuum and how much resources, time, experts you can kind of put together for the thing to make that happen.
Can I ask just a really naive kind of question, but that's often been in my head. So I think you mentioned in relation to this issue of detecting AI-generated images versus real images, one kind of feature that seemed to show up a lot in at least early AI-generated images is things like the wrong number of fingers on hands. I'm just curious about how does that problem arise? Because it seems like the training data overwhelmingly would show the right number of bands. Right, like, I mean, yes, there are anomalous cases, but
Is that, so not all images you see all 5 fingers, right? And the model doesn't have a way how to explicitly count the fingers because the model actually doesn't know what a finger is. It just has some local neighborhood. It knows that next to this type of finger is usually another one, another one, another one. And so, okay, so if the hand is frontal, it will generate the 4 fingers. But when it's like this, you really see only 3 fingers, and that's okay. But in order to understand the difference between this and this, you need to know what the body is doing. And the model usually doesn't have such a big context, right? Because it's kind of looking only at the local neighborhood. So it's a little bit like the language model context, So the way how the models kept on improving is that the answer would be generating given the making the prefix longer and longer, so the model could really understand the entire context of the generation. So you can give it a murder mystery and then ask who murdered the person, but all the clues are somewhere kind of spread throughout the book. And so if you just give it several thousand of words, that's not enough. But if the context is large, and in the context of images, it's kind of the neighborhood, kind of a little bit, at least kind of that's one explanation, but that would be more specific.
I thought that was always a cool example because for like painters and portrait artists, hands are notoriously difficult, right? So it's like this funny thing where it's like, we can't do it, they can't do it. Like there's some commonality there. Hands are hard.
Oh, yeah?
Yeah.
Are there any other questions? I think those are mostly common.
No, we just got a couple links shared.
Mhm.
Zoom, no questions.
Well, thank you all very much and thank our speakers. And hope you'll join us for the next session in the series as well.